Okay, 2012 AMC. This is problem 7 from the AMC12A and problem 10 from the AMC10A. And this one, the way I'm going to solve it's a little bit of a number theory concept, but Mary divides a circle into 12 sectors. The central angles of these sectors measured in degrees are all integers, and they form an arithmetic sequence. So we have all integers and an arithmetic sequence. What is the degree measure of the smallest possible sector angle? Now, I'll draw a little circle. We know that no matter how many sectors I have, and so it's divided into, let's see, 12 sectors. So something like this. They're actually, none of them are equal. And I know that the sum of all of these angles must be 360. But here's where it becomes solvable, where we can get some answers. An arithmetic sequence means that my first number, my smallest angle, will be some measure x. And then every angle after that will be some number y more than that. So first term of the sequence is x, common difference of y. So we get x, x plus y. And these are all in degrees if I want to measure the angles, but we're looking just at the strict number here. X plus 2y all the way up to x plus 11y. To get to the 12th term, I had to add y 11 times. The sum, I'll just write sigma notation, but this means the sum as k goes from 0 to 11 of x plus ky. So this is basically saying this exact thing. Adding up all of these, x plus y, we know we will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. And now the y's. Well, we should know the sum of an arithmetic sequence. So notice we have 0 y's. So let me write this out. So the y's. We have 0y plus 1y plus all the way up to 10y and 11y. That's the last amount of y's we have. And if I look at this, if I take the first and last term, you've probably seen this before, and I add those two, I get 11y. If I take the second and second from last term, I get another 11y. So 1y plus 10y. If we have 2y and 9y, I have another 11y. And since there are 12 total terms in here, I have 6 11y's, which is of course 66y. Okay. So back to this. So the sum was 12x plus 66y. But I know that the sum of all of the central angles in a circle are 360 degrees, so I have to solve this. 12x plus 66y equals 360. And these numbers are kind of big. I notice they are all divisible by, or 6 divides every term evenly, so I know that I get 2x plus 11y equals 60 by dividing out that factor, that common factor of 6. And now, probably the easiest way to see this is just figure out what could y be as an integer. So y could be anything 0 through 5. If y is less than 0, we wouldn't, x wouldn't be the smallest term, it'd be the biggest term. And if y is bigger than 5, then x would be a negative angle, and that's not going to work out so well. So y could be anything 0 through 5, and basically, so if y equals 0, so let's say if y equals 0, then 2x plus 11 times 0 equals 60, and our smallest angle here, that cancels out, divided by 2 is 30. And that makes sense. It's 30, 30, 30, 30. If I have 12 30s, I get 360 degrees. If y is 1, and I'm just going to skip these steps, so we have 11, we subtract 11, we get 49, we get 49 halves. That can't work out because that gives me a decimal for a fraction for x. If y is 2. We get 2x plus 22 is 60, so we get 38. We divide that by 2, and we get x equals 19. If y is 3, we put it in, we get 2x plus 33 equals 60. We divide, we get 27, or subtract, divide, we get 27 halves. Decimal, no good. If y equals 4, well, 2x plus 44, subtract the 44, we get a 16. Divide by 2, we get that x equals 8 degrees, or 8. And then if y is 5, we get 2x plus 55. And so 2x equals 5, we get 5 halves, that doesn't work. So my answer is 8C. And for those that want to keep watching, I'll fill in the work here. But if you get it, stop going to the next video. So the work here, basically I had 2x plus 11 times 1 is 60. 11 times 1 is 11, subtract from both sides. 2x is 49. So x equals 49 over 2. And I cannot get an integer for that. This one, we saw we had 2x plus 11 times 2 equals 60. 11 times 2 is 22. Subtract it, we get 38. So 2x equals 38. And we see, okay, 19. This one I'm going to bring down a little bit because I have some more room. So 2x plus 11 times 3 equals 60. And 33, subtract it, 2x equals 27. So x equals 27 halves, no good. This one, 2x plus 11 times 4 equals 60. So subtract that, so 44, subtract it off from both sides, 2x equals 16. So x equals 8, and this one, 2x plus 11 times 5 equals 60. And 55, subtract it, 2x equals 5. So x equals 5 halves, and that's no good because we have to have an integer. All right,